Hi, boys and girls. We're going to start in on our next lesson on magnets, lesson 2, What Do Magnets Attract? To start today, we're going to read a story called Magnets, Pulling Together, Pushing Apart. This is a nonfiction book written by Natalie Rosinski, illustrated by Cherie Boyd. It has a table of contents. Will give us an idea of what we're going to learn. Amazing magnets. How do magnets work? Magnetic earth. How does a compass work? Magnets all around. Experiments. There's a glossary to learn more and an index. Okay, so the glossary is going to give us some definitions for words we'll find in this book. An index is at the very back, and it will help us to find very specific information we're looking for. But for right now, I'm just going to read through this story, starting with chapter on amazing magnets. Magnets have the power to make things move. When strings pull and lift things, it's easy to see how they work. Magnets seem to make things move by magic. She's got a little puppet marionette that has the strings. Watch a paper clip scoot to a magnet. The paper clip slides along as if pulled by an invisible string. And anytime we see captions or insets of words, we want to read them because often there is information in there we need. Magnets pull only on special kinds of metal. Try to move a steel spoon or an iron nail with a magnet. Now try a ball of cotton, a rubber ball, or a plastic ball. How do magnets work? Magnets can only pull on things that are close enough to them. So it has to be close. It can't be super far away. Put a paper clip far away from a magnet. Slowly move the paper clip closer and closer. How close does it get before it leaps toward the magnet? And again, we're going to read this caption or inset that's going to tell us more about this. Magnets can work through a covering if it is thin enough. Lay a sheet of paper over your magnet and place the paper clip on top of the paper. Or try putting a piece of plastic wrap or the corner of your shirt on top of the magnet. Now, or what happens to the paper clip now? Dangle an iron nail from the end of a magnet. Now touch a paper clip to the nail. The paper clip sticks to the nail. The nail has become a magnet. When some metal objects touch or get close enough to magnets, the metal objects become magnets. Pull the nail away from the magnet. Does the paper clip still cling to the nail? Rub a steel spoon along a magnet. You can feel the spoon being pulled toward the magnet's ends. These ends are called poles. A magnet's power is strongest at its two ends. One end is called the North Pole. The other is the South Pole. We just talked about poles, but they were on our globe. Fun fact, if you break a magnet apart, you have two new magnets. Each separate piece has its own north and south poles. So you can see this original magnet, when it was together, it had a south pole and a north pole on each end, but then when it got broken, this end became the south pole and this end became the north pole, so they each had one of each. The poles of a magnet can push as well as pull. Poles that are alike repel each other. That means they push each other apart. The north pole of one magnet will push away from the north pole of another. A fun fact, in Japan, some high-speed trains are extra strong magnets. Magnets on the train repel or push against magnets in the track. The train seems to glide on a cushion of air. So that's another place where magnets are used in everyday life on trains. opposite poles attract each other. One magnet's north pole will stick to the south pole of another magnet. So it pulls towards each other when they're opposites. Magnetic Earth. Earth is a giant magnet. It has two ends or poles, just like other magnets. Hey, we just talked about that. Earth's magnetic ends are close to the north and south poles that are shown on a map, or a globe or a map. The cold North Pole and South Pole, covered with ice, are not the same as Earth's two magnetic poles. How does a compass work? Earth's magnetic power pulls other magnets. The needle on a compass is a tiny magnet. The needle always lines up in a north-south direction, pointing toward the magnetic poles of Earth. Here's another fun fact. A compass won't work if you're standing too close to the cold North Pole. The needle points to Earth's magnetic pole. Once you travel past the magnetic pole, the needle does not point northward anymore. So if you are so close to the North Pole you need a compass, you might be in trouble. A compass shows us what direction we are moving in, north, south, east, or west. Sailors once used compasses to cross the ocean and to find their way back home. Magnets all around. Some of Earth's rocks have magnetic powers. Long ago, the Greek and Chinese people discovered the rock magnetite. Another name for a piece of magnetite is a lodestone. We learned that yesterday. Lodestones were used to make the world's first compasses. The Greeks were amazed as they watched magnetite pull small pieces of iron. The ancient Chinese hung splinters of magnetite from strings and watched the rocks line up in a north-south direction. Today, electric fans whirl, refrigerators hum, and burglar alarms ring with the help of magnets in their motors. Huge magnets help junkyard workers lift tons of scrap metal. These magnets move cars and trucks as if they were small toys. Doctors also use magnets and special machines to look deep inside your body. Magnets push and pull us all around the world. Then we have a list of experiments. And then on this back page is the glossary. It tells us what words mean. Some books you can get to learn more. A fact hound, search, and an index. An index is where you can find specific information. So if I wanted to find specific information in this book about the junkyard magnets, I would look on page 20. Okay, so now that we've done that, we are going to conduct a little experiment. So while I'm getting my stuff out, where did I put it? Here it is. We're going to conduct an experiment. So based on what we learned, we are going to test some objects to see if they are magnetic or non-magnetic. So before a scientist studies something, they make what's called a hypothesis. A hypothesis is a guess as to what they think will happen. So looking at these, I want you guys to guess what you think will be magnetic and what you think won't be magnetic. So you're going to make a hypothesis. So for instance, I'm going to look at this rubber band. Even though it's a broken rubber band, I'm going to guess that it is non-magnetic. And what I'm going to do is I'm going to put it aside over here and I'm going to take a magnet. I have a magnet here. And I'm going to see if nope. So that would be non-magnetic. I'm going to put it over here in a pile. All right, let's try this. What do you think? Do you think this will be magnetic or non-magnetic? It's a penny, if you can't tell. Here, I'll turn it over so you can see Abraham Lincoln. There he is. Okay, let me try it. Nope, doesn't look like it's magnetic. Nope, so I'll put it in non-magnetic. How about this safety pin? What do you think? Magnetic or non-magnetic? Oh, that was fast. Let's do it again. Oh my goodness. And look, whoa. It doesn't. There we go. So that is definitely magnetic. We'll put it over here in a magnetic pile. All right, what about this cube here? It's kind of hard to see. Let's check. Nope, non-magnetic. How about this crayon? What do you think? Magnetic or non-magnetic? Nope, non-magnetic. How about this piece of styrofoam? It's like comes in a package from Amazon. What do you think? Magnetic or non-magnetic? Nothing. Okay. How about this screw here? Oh! Okay, I think that's magnetic. Let's try it one more time. Yep, that's magnetic. What about this here? This is a little straw. What do you think? Magnetic or non-magnetic? Nope. This is a nut that goes on the end of a bolt. So what do you think? Magnetic or non-magnetic? That is definitely magnetic. All right, how about this? This is at the top to a pop can, soda can. Ah, I thought that one would definitely be magnetic. Nope. What's this one? This is a popsicle stick. Let's see what we think. Nope, non-magnetic. And this is a paper clip. Oh my goodness, look. Oh, it moves from kind of far away, doesn't it? Okay, so that's magnetic. So we've got, these are our magnetic ones and non-magnetic. Now, if you have a magnet at home, you can try this experiment to see if it attracts objects, and then you can decide, make a hypothesis before you try it to see if you think they're going to be magnetic or non-magnetic. Now, what we're going to do is, right now, is we're going to take some notes on this lesson. So, what I want you to do is get out your fact files. And you are also going to need this set of notes. So if you would please get those out, and then I'm not sure what happened to my glue stick. Oh, it's right here, right where I needed it. Okay, so we're going to open up to the next blank page. There's my notes from yesterday, so I'm just going to go right on the back. Make sure I'm not skipping pages. And I'm going to glue this right in there. All right. So get that glued on. If you need to pause, go ahead and pause. And I am going to get ready for our next one. Okay. So magnets attract most items containing the metals. There's 3 metals that they usually contain: iron, cobalt, and nickel. So here we go. So we are going to write down iron, cobalt, and nickel. So if you need to pause it there, you can and get caught up with those notes. Then our last note says magnets blank attract materials made of wood, plastic, or aluminum. So we're going to put the contraction for will not in here, and that is the word won't. W-O-N''T. Won't attract materials made of wood, plastic, or aluminum. And we found that out in our experiment. It didn't attract the popsicle stick. It didn't attract the soda can tab. That's made of aluminum. It didn't attract the plastic cube either. So it doesn't attract things made of wood, plastic, or aluminum. So if you do any experimenting, let me know how it goes. Maybe you can write down what you think it'll attract and what you don't. Find stuff from around the house, put it in a pile, and start sorting it once you've tested it. Thanks for listening, guys.